All right, so I got the 5-4 homework up, I think. All right, so on number 1 and 2, you're supposed to factor and solve, and you're supposed to find all complex zeros. All of them. That means real and complex. So here is a sum of 2 cubes pattern. To become 8x cubed, I have to take a 2x and multiply it by itself 3 times. And to become 125, I take a 5 and I multiply it by itself 3 times. And again, don't mute me. Case and Allen, don't blindly copy. So I figured out that A is 2x, B is 5. This is 2x plus 5. If I square a 2x, that's 2x times 2x. Think about all of it at once. That's 4x squared. Minus because there's a minus. 2x times 5 is 10x. Plus because there's a plus. 5 times 5 is 25. And you're supposed to find all your real zeros. When we did this in the past, the only thing we cared about was the first one. 2x plus 5 is 0. Move over makes it negative. Divide by 2. Negative 5 halves. Most of you can do that. Sadly, it's not all of you. You're going to have to write kind of small here, but you're going to have to use the quadratic formula for this guy because there's 2 imaginary answers there. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So inside that radical is 100 minus 400, which is negative 300. All over 8. Now, in my head, I think negative 300 is the imaginary root of 100 times 3. And the root of 100 is 10, so 10i root 3. Now, I've got a 10 over an 8, and I'm about to have a 10i over an 8. Those both reduce to 5/4. So x is 5/4 plus or minus 5/4, the imaginary root of 3. And that's it. 3 is using synthetic division and your graphing calculator and the quadratic formula, perhaps. Find all the complex zeros of that thing. All right. So let me pull up a TI-84 here. This is usually when my tablet goes wacky. By all means, play along at home. You know who you are. I mean, you know whether or not you can do what I'm doing. But you just in la la land thinking everything's going to be okay. It doesn't matter how much I like you. If your grade says you fail, you fail. I don't understand why that's such a hard concept for us to grasp. It's just the way things are, kids. Quit making excuses, put in the work, you'll be fine. All right. Assuming I made no typos, zoom 6. Ugh. I wonder if this is a nice 0.5 and what some of these are. Some of these are pretty easy to figure out. Like that's obviously 4. That's obviously -1. And that is going to be negative, what, 4.5 maybe? Let's put a 0 in here, y2. And I do want you to use the quadratic formula. So I need to find 3 good ones. Let's just see what that first one is. Close. Yeah, that's not a pretty number to do synthetic division with, is it? Second trace 5 again. I'm pretty sure this one all the way to the right is at 4. Oh man, I missed it. Got to pay attention to what's going on down here. It went from negative 82 to 139. Enter, enter, enter. It's at 4, so there's 1 0 I can use. All right. See what that one is. Enter, enter, enter. Negative 1 is one I can use. That one right there is ugly. Scroll all the way to the left. See what's here. Enter, enter, enter. Ah, no, it turns out this is the one I want. Second trace 5. Enter, enter, enter. Okay, negative 1.5. So I got 3 good zeros from my graph. I was 4, negative 1, negative 1.5. So x equals 4, negative 1, negative 1.5. And I'm just going to synthetically divide those out. And that's going to get me down to a quadratic. I'm going to go with a 4 first. My coefficients are 2, 3, negative 30, negative 57, negative 2, and 24. And I drop, and I multiply, and I add, 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 and I multiply, and no surprise, I got a 0. Now I'm going to repeat the process, this time with the negative 1. I'm going to save that negative 1.5 for last because it's, the most complex thing to do. Negative 1 times 2 is negative 2. 11 minus 2 is 9. Negative 1 times 9 is negative 9. That funky looking number there was a 14. 14 minus 8 is a 6. Negative 1 times 6 is negative 6. And we have a problem, Houston, don't we? That's negative 9. There's my problem. Five. There we go. Negative 1 times negative 6 is 6, 0. All right, drop the 2. 2 times negative 1.5 is negative 3. 9 minus 3 is 6. Negative 1.5 times 6 is negative 9. 5 plus a negative 9 is negative 4. And negative 1.5 times negative 4 is 6. And there we go. Remember, remainder, constant, x squared. So the quotient that's left is 2x squared plus 6x minus 4. I'm going to set it equal to 0. And I'm going to pull a 2 first to make the numbers smaller. And then I'm going to hit it with the quadratic formula because it doesn't factor. There are not factors of negative 2 that add to positive 3. They do not exist. At least they don't exist as whole numbers. You put it that way, or integers. So x equals negative b. B is 3. Plus or minus square root b squared minus 4 times a, which is 1, times c. all over 2a. All right, what do we have here? We have 9, a negative times a negative is positive, plus 8, which is 17, and it's over 2, and so is that. And that's as far as you can go. But you have 3 zeros here, you have 2 zeros here, total is 5. It's not that bad. It's really not. All right, we have radical equations. Solve the following radical equations. Make sure to check your solution. Checking is not optional. All right, so let's see here. We always do the easy stuff first. Always. So we're going to add 6. Negative 4 roots of x is now negative 14. This thing's not pretty, is it? It's really not pretty. We're going to divide out the negative 4. Root of x is 7 over 2. Negative 7 over 2. Sorry, that was a negative over negative, positive 7/2. And now the opposite of square rooting is squaring. So we're going to do the inverse operation. The inverse of square rooting is to square. Now 7 times 7 is 49. 2 times 2 is 4. So here's x. Does this actually work or not? I don't know. Let's see. Negative 4 times the square root of 49/4 minus 6 is negative 20. So the root of 49 is 7. The root of 4 is 2. Negative 4 times 7/2 minus 6 is supposed to be negative 20. And this is true because negative 4 times 7 is negative 28 over 2 is negative 14. That is true. So it works out. All right, number 7, we're going to add 73 to 170, and that's going to give us 243. And now we have x minus 5 to the 5/3. I feel like writing this like this: the cubic root of x minus 5 to the 5th. Because you need to understand that rule. So the opposite of cubing, cube rooting, or the inverse, is to cube. So I'm going to cube both sides. I have zero desire to write down 243 cubed. Now I have x minus 5 to the 5th is 243 cubed. The opposite of the 5th power is going to be the 5th root. And here we are. Now, I can do certain things. What I can do here is I can take the 5th root of 243 and then cube it. Now, most of you guys are just going to push buttons on a calculator. And you're going to think, oh, you're so smart. Yeah, you're really not. You're really not. 5th root of 243 is 3. I have to cube it, and I get 27. So x minus 5 is 27. Add 5, x is 32. All right. I'm going to do probably one more, and then classes are about to start. 9 is where it starts, and I didn't go back and check, but because I know I'm right. 9 is where it starts getting a little more challenging. The opposite of a square root is to square. And to square something, you have to write it twice. Now, when you square this, the radical cancels. You're left with x squared plus 4. Here you've got to do x plus 5 times x plus 5, which I'm going to do off to the side. And if you FOIL that, you get x squared plus 10x plus 25. Now, we're going to shift everything right. The x squareds are going to cancel. We'll have a 10x and plus 21. Now we're going to shift the 21 over. Negative 21 is 10x. We're going to divide by 10. X is negative 21 tenths. Again, I don't really feel like checking that, so I'm not going to. 11. 11's like super easy. The opposite of square rooting is to square. 4x plus 1 is x plus 10. X is on one side, numbers on the other. 3x is 9, x is 3. And I do have a little more time here. So let's do 13. 13 is a good stopping point. 13 is going to be a little more work. I'm going to isolate the left-hand radical. You can either isolate either one of them. Why I chose the left-hand radical, couldn't tell you. It just felt right to me. And now I'm going to square both sides. And here's where it gets fun. The left is super easy. It's 2x plus 3. The right-hand side, you got to write that thing twice. And you got to do the double distributive property. Radical times itself is what's inside. We'll have 1 root 3x3 plus another root 3x3, so plus 2 root 3x plus 3. And then we'll have plus a 1. And now we get to play the isolation game again. This needs to be isolated. That root does. So we'll move everything left. 2x minus 3x is negative x. 3 minus 3 is nothing. Nothing minus 1 is minus 1. And that's equal to 2 roots 3x plus 3. I've seen lots of people teach this differently. I like to divide things out before I square. So I'm going to divide by 2. Now I'm going to square both sides. Bottom's easy, that's 4. When you write negative x minus 1 twice like you're supposed to, negative x times negative x is x squared, plus an x, plus another one, plus 2x, and then plus 1. And that is now equal to 3x plus 3. I don't like the fact that there's a fraction, so I'm just going to 4 everything. Now I'm going to shift my x's left, everything left actually. 2x minus 12x is 10x, 1 minus 12 is negative 11. And now I'm going to factor x minus 11, x plus 1, because negative 11 times 1 is negative 11, so forth, still equal to 0. X is 11 or x is negative 1. Whew. Question is, do they both work? So if I put an 11 here, that's 22, plus 3 is 25, root of 25 is 5, 5 plus 3 is 8. If I put 11 here, that's 33 plus 3, which is 36, root of 6 plus 4 is 10. This bad boy right here is extraneous because you got 8 equal to 10, which isn't true. If I plug in a negative 1, I'd have root 1 because negative 2 plus 3 is 1. The root of 1 is 1, 1 plus 3 is 4. If I plug it in here, I would have root 0, which is 0 plus 4. This one passes the test. And that's a good stopping point. So that's the first part of 5-4.